Hi, let's take a look at a motion problem. Um, this is not too complicated, but it has multiple parts to it. So let's see if we can figure it out. So the problem is, JoElle is out for a Sunday drive. She drives north along the coastal highway, driving at 40 miles an hour for 80 miles. She then turns around and drives south for 30 minutes at 60 miles an hour. So we're wanting to know, how long did JoElle drive north? How far south did she drive? What was her average speed for the entire trip? What was her average velocity for the entire trip? So when I start working on problems like this, one of the first things I want to do is write down the information that I know. And so we're going to say driving north. Um, so we're going to say that her velocity north is equal to 40 miles per hour. And we also know that her displacement north, or her distance north, is equal to 80 miles. So we're really talking, by the way, speeds here, but we're going to use V for that. Then she drives south for 30 minutes. So we know that, and she drives at 60 miles an hour. So her speed or velocity south is 60 miles per hour. Now we know that the time she drives south is 30 minutes. 30 minutes. That looks kind of like a 36. I want it to be a 30. Let's just make it look the way it's supposed to look. 30 minutes. Okay, so how long did JoElle drive north? Well, we can figure that out using the equation that we have. So I think I'll switch over to green for that. So we know that speed is equal to distance divided by time. And so if we want to know the time, we just solve that equation for t. So I multiply both sides by t and I divide both sides by s. Time is equal to distance divided by speed. Well, the distance that she drove north was 80 miles, and the speed she drove north was 40 miles per hour. And so 80 divided by 40 is 2. And notice that the miles will divide out of this equation. And I kind of got no units up here over 1 over hours. So if you were to simplify that, it comes to hours, which of course it should, because we're looking for the time. So the second part, which I'll do this way, is maybe switch colors. The second part of this problem was, how far south did she drive? Okay, so what we know about the south is that right there. We know that she drove at 60 miles per hour, and she did it for 30 minutes, which, by the way, with the units all have to be the same. This is 0.5 hours, of course. Okay, so I'm going to use the same equation. What was her average, or how far did she drive? So if I start with speed equals distance divided by time, and I'm looking for distance, this would mean that distance is equal to speed times the time. So the distance here would be the speed, which we said was 60 miles per hour, times the time, which is 0.5 hours. And I think you can see that 30 times 5.5 is, or rather 60 times 0.5 is 30. The hours divide out, and I get miles. And so that's the answer to how far she traveled. That was the answer to the time. Okay, so now the problem asks, what was her average speed for the entire trip? So I'm going to put that one right over here. Part 3, speed for the entire trip. Again, speed is equal to distance divided by time. Okay, so if we look at this, the distance, how far did she drive? Well, she drove 80 miles to go north, and then it says she drove back and went a distance of 30 miles. So 80 miles plus 30 miles, that would be the total distance that she drove. How long did it take her to do that? Well, we know from part 1 that she drove for 2 hours, and for part 2, we know she drove for half an hour. So we have 2 hours plus 0.5 hours. So the speed then becomes 110 miles divided by 2.5 hours. And if you do 110 divided by 2.5, you get 44. So her average speed was 44 miles per hour. Now, when we go to look at her average velocity, so this is part 4, I'll just do that right there. Her average velocity. So average velocity is defined as the total displacement divided by the total time. And this would be an initial position minus a final position divided by the time it took. Now, let's take a look at this. We know that we have to come up with some kind of a coordinate system here. So she's driving along the coastal highway. Let's say this is the coastal highway right here, okay? And she's going to start right there. And we're going to call that x naught equals 0 miles. We get to make that choice. And so that seems like a simple one for us to do. And so she drove north, and she went 80 miles. So she got up to this point right here, which was 80 miles. And she turned around and she drove back another 30 miles. So she ends up here. This is her final position. So if she started at 0, she goes up to 80, then she moves back 30. This is 50 miles. That's how much her position changed. So we end up with 50 miles. It's her final position, minus 0 miles, which is her initial. And again, I could have chosen any number I wanted there. And we still know that it took 2.5 hours. So if we solve that, you get 50 miles divided by 2.5 miles per hour, and her average velocity for the entire trip is going to be 20 miles per hour. Actually, I put miles per hour there, and that is not the correct unit for this. So I don't want to confuse people with that. That was 2.5 hours. And so that is her average velocity. Please notice it's not the same as her average speed, because average speed is the rate at which you cover distance. So it's the distance divided by the time. Whereas average velocity is the rate at which your position changes. So it's displacement divided